So in the last class, I have given you this question to attempt. Now let's see how you will attempt it. First, if you see, these are the initial moles of SO2. Then we have our initial moles of oxygen as well, right? And then at equilibrium, we got the total pressure, that is PT. And these are the equilibrium moles of SO3. So what was the first thing that you guys would do to find the moles of each gas at equilibrium? So,
Sir, make the ice table.
yeah, very good. So what we are going to do, we are going to make the ice table over here. So we have initially 2 moles of sulfur dioxide and 2 moles of oxygen, which were put in the flask. So there is no moles of sulfur trioxide. Then at equilibrium, there are 1.8 moles of sulfur trioxide. So if you see, the change for sulfur trioxide is positive 1.8 moles. Now, if you compare these two has a mole ratio of 1:1. So if the product is 1.8 moles formed, so it clearly indicates that here the change for SO2 would be negative 1.80. And when we subtract these two, we will get 0.02. So these are the equilibrium moles of sulfur dioxide. Now, if you take the ratio of these two, it's 2:1, which means that if there are 1.8 moles of sulfur dioxide are used up, then half of these moles for oxygen would be used up. So if you half it, you will get 0.9. So here the change would be minus 0.9. And if you subtract it, you will get 1.1 moles of oxygen at equilibrium. Is this understandable to all of you?
Yes, sir.
Okay. Now we will find the total moles. The total moles would be 0.02 plus 1.10 plus 1.80. So yes, what are the total moles? 2, 2.9. Are they 2.92?
जी सर.
Okay.
Yes, sir.
So we got the mole fraction, which is 2. Total moles. Now we will find the mole fraction of each gas because you have to find the Kp. So mole fraction of SO2 would be moles of SO2 at equilibrium, which are 0.02, divided by total moles, which are 2.92. For mole fraction of oxygen, moles of oxygen, which are 1.1 divided by 2.92. Then we have a moles of sulfur trioxide, which are 1.80 divided by 2.92. Yes, can anyone calculate and tell me the mole fractions of each of the gas?
Sir, the first one is coming 6.85 into exponent negative 3.
6.85 exponent negative 3, right?
Yes, sir.
Then for second one,
Sir, it's 0.376.
0.376. Then for third
Yes.
one,
Sir, 0.6164.
0.616.
6164.
Okay. Now,
Yes.
if you add these three values and on adding this, if you get 1.0 or 1, so it means you have found the mole fractions correctly. So you can just cross check it. Now, after this, we have to find the partial pressure of each gas. So the partial pressure of sulfur dioxide would be its mole fraction times partial pressure, total pressure, that is 2 exponent 5. Partial pressure of oxygen would be mole fraction of oxygen times partial pressure, total pressure. And then partial pressure of sulfur dioxide would be mole fraction of sulfur trioxide, which is 0.616 times total pressure. Can anyone solve it and tell me the values, please?
So the first one is 1370.
1370.
Yes.
Second one. Okay.
Sir, 75200.
75200. What about third one?
Sir, 123200.
123200. Okay.
Yes, sir.
Now if I have to find the Kp expression, Kp, so first see Kp expression. So Kp expression would be, if you look at the equation on the left, partial pressure of SO3 square divided by partial pressure of SO2 square times partial pressure of oxygen. So the partial pressure of SO3 is 12320 square divided by 1370 square times 75200. Now if you will calculate, you will get the Kp value. And if I work for the unit, so square above and below would cancel out, and it's Pascal. So we will get a 1 Pascal in the numerator, in the denominator. So the unit would be Pascal inverse. Is this clear to all of you?
Yes, sir.
Just tell me the Kp value.
Sir, 0.1075. 0.108.
0.108. Yes, Kubra, Hamza, Yusuf, is this clear?
Yes, sir.
जी सर
Yes, sir.
Okay. Now we will going to see the application of equilibria reversible reaction in the chemical industries, where it's used and how the different conditions are used to get the maximum, yield. Mhm. So there are two chemical processes where equilibrium is actually, applied. One is Haber process and the second one is contact process. Okay. So equilibria in industry. Number one, we have Haber process. It is the industrial production for ammonia. We use this process to produce ammonia in industries. So in this reaction, nitrogen gas reacts with 3 moles of hydrogen gas, forming 2 moles of ammonia gas. And here the catalyst used is iron, and the enthalpy change of this reaction is minus 92 kilojoule per mole. Just you guys, please just give me a minute. Now, so we will apply the Le-Chatelier principle and see how the maximum yield obtained. So as the reaction is exothermic, the forward reaction is exothermic and the backward reaction is endothermic. So to obtain maximum yield of ammonia, the conditions must be, what do you think in terms of temperature and pressure? What temperature we need a higher temperature or a lower temperature? And in the same way, a higher pressure or a low pressure? Yes, if we want to shift the equilibrium towards right more and more, whether we need to increase the pressure or decrease the pressure. Yes, who will tell me?
Sir, increase the pressure.
Why?
Sir, rate बढ़ेगा ना तो उससे फिर
The rate would increase, but this is not the equilibrium position. We have discussed in detail where the position of equilibrium shift on increasing or decreasing the pressure, and in the same way when increasing or decreasing the temperature. So why we increase the temperature? Why we increase the pressure? And what about temperature? Whether we increase the temperature or decrease the pressure temperature? Yes, who will tell me? Please quickly. No one of you is revising the things, right? See, here we have a 2 moles of gases and here we have a 4 moles of gases. So when we increase the pressure, equilibrium shifts in a direction where there are lesser moles of gases. And if we decrease the pressure, equilibrium shifts in a direction where there are more moles of gases. So we have a 2 moles of gases. There are fewer moles on the product side and we need a higher product. So we need to maintain the high pressure. Why guys are not revising the things? Yes, Hamza, Yusuf, Ashal, Kubra, no one is revising. And the pressure is actually maintained is 200 atm. If we increase the temperature, equilibrium shifts towards the endothermic side. And if you see, this is exothermic, which means forward reaction is exo and backward reaction is endo. So if forward reaction is exo, to make more product, we will have to lower the temperature, because when we lower the temperature, equilibrium shifts to the exothermic side, and the exothermic side is forward. Is this clear to all of you?
Yes, sir.
Yes, sir.
So low temperature would use. But in actual, if lower temperature is used there is a problem with the low temperature, and it is that at low temperature, obviously we are going to get the higher yield, but it will take more time, and economically it's not feasible for the industry. At low temperature, rate of reaction slows down. Hence, 350 degrees Celsius temperature is maintained. And see, it's not a lower temperature. So that's why we call this temperature compromising temperature. It means that we are compromising on the temperature conditions, because if we lower the temperature, we will not get the ammonia in actually quickly. It will take a lot of time to form ammonia. And as it takes a lot of time, the chemical plant would run for that much time. So much energy is being used up. Is this understandable to all of you?
जी
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now, the second thing that we have is contact process. Now the whole process is not the part of the syllabus, so we just look, it is the production of sulfuric acid. It is the industrial preparation of sulfuric acid. So we will not discuss the whole process. We just only discuss the equilibrium reaction. The equilibrium reaction is the one in which sulfur dioxide gas reacts with the oxygen gas, forming sulfur trioxide gas. And the enthalpy change for this reaction is minus 197 kilojoule per mole. So it means that this reaction is also exothermic, right? And here the catalyst we use is V2O5. Okay. So here again, what temperature and pressure conditions we need according to the Le Chatelier principle to gain the maximum, to obtain the maximum yield? Yes, who will tell me? To obtain maximum yield, of
सर
sulfur.
टेम्परेचर डिक्रीज
Sorry?
टेम्परेचर डिक्रीज करेंगे
Yeah, that lower temperature would use. So to obtain the maximum yield of sulfur trioxide, and what about pressure? We need a higher pressure or a lower pressure? Yes. See, there are 2 moles of gases, and here we have a 3 moles of gases. So again, lesser moles are on the product side. We will increase the pressure, higher pressure would use. So according to the Le Chatelier principle, a lower temperature and higher pressure low temperature and high pressure. Further, just give me a minute, please. Okay, so further SO3 is removed. So the equilibrium would again continues to shift in the forward direction if we remove the sulfur trioxide periodically. Okay, but again, for the same reason, temperature that is maintained over here is 400 degrees Celsius. So see, we are not maintaining the lower temperature, and it's for the same reason that I have discussed earlier. So it's called compromising temperature. We are compromising on the temperature conditions. Is this understandable to all of you?
Yes, sir.
As lower temperature slows down the rate of reaction. Further, 1 to 2 atm pressure is applied. See, the pressure over here is also not much high. It is because the pipes are not that much stronger, so they would burst on higher pressure. That's why we use a lower pressure as well. So the pipes would not burst. Yes, is this clear to all of you?
Yes.
Okay. Mm. The next thing that we are going to discuss over here is about acids and bases. So how could you define an acid? Yes, anyone? No one knows what is acid? So acids are compounds which dissociates or ionizes to produce hydrogen ions in aqueous solution. So in aqueous solution, when the hydrogen ion produce, then that is acids. When we talk about bases, so we say compounds ionizes to produce hydroxide ions in aqueous solution. So, but this is the old definition which you have studied in O levels. Okay. So, what is a proton? Can anyone tell me what is a proton? Yes, Ashal Kubra and Yusuf, who can tell me what is a proton?
Uh,
Proton is a subatomic particle which is present in the nucleus of an atom, right?
yes, sir. Positively charged.
Yeah. So, hydrogen ion is also a proton. And see how. Let me show you how. As it has one proton only, and the reason behind this, if you see, this is a hydrogen atom. So if hydrogen atom, it has a one proton, if we talk about neutron, there are no neutron. And how many electrons it has? One electron. But when it becomes an ion, now it's a positive ion, which means electron is lost. So it has a one proton, no neutron, and no electron. So see, hydrogen ion has also, if we observe it, we will find it also has just a proton in it. So that's why we call hydrogen ion a proton. Is this clear to all of you?
Yes, sir.
So that's why we call it a proton. Now, we are going to discuss a new theory for acid and base, which is called Bronsted-Lowry acid. So whenever examiner asks you to define Bronsted-Lowry acid, so you will write that it is a proton donor. Now we have Bronsted Bronsted-Lowry base. So how will we define the Bronsted-Lowry base? We will define it that it is a proton acceptor. So it's a proton acceptor. Okay. So have a look over here. We have an equation where we have a hydrochloric acid. And this hydrochloric acid is reacting with the water. Now, if you look at the product, a chloride ion would form and hydronium ion would form. So if you compare this and compare its related with the product made from it, so you can see it has a hydrogen and product doesn't has a hydrogen. So it means it is the one which donates its protons. So it is called Bronsted-Lowry acid. Is this clear to all of you? Now, if you look at the water,
Yes, sir.
water has two hydrogen and here it has a three hydrogen. So see, according to the definition, it is the one which is accepting the hydrogen ion. So we call it Bronsted-Lowry. We call it Bronsted-Lowry base. Is this clear to all of you?
Sir,
Yes.
okay, sir, it's clear. No, it's clear.
Okay. Okay. Now, another important thing over here to understand is after donating H positive ion, the species, or you can say the atom or a group of atom, left behind is called conjugate base of that acid. So in the above equation, the Cl negative ion is the conjugate base of HCl. Is this understandable to all of you? And then both acid, which is the bronsted acid, and its conjugate base are called conjugate pair. So see, this is the one which loses the hydrogen ion. On losing the hydrogen ion, chloride ion would left. So it is the conjugate base of this acid, and both are collectively called conjugate pair. Okay. Now what base is doing? It is accepting the protons, right? So after accepting hydrogen ion, species formed is called conjugate acid of that base. So in the above case, water is a base, so H3O positive, which accepted the which is formed by water when it accepts the hydrogen ion. So it would become the conjugate acid of that base. And this both base and its conjugate acid are called conjugate pair. So these two are also called conjugate pair from, but it means that from the above equation, one conjugate pair is HCl and Cl negative, and the other conjugate pair is water and H3O positive. Is this clear to all of you?
Yes, sir.
Okay, then.
Yes, sir.
We will look at their few examples, and then we will do the indicators and the titration curves in the next class. For today's class, I will keeping it till here only.
Okay, sir.
Is this clear to all of you? Okay, then take care, everyone. Allah Hafiz.
Allah Hafiz.